Scientific notation is basically a shorthand notation. It will always be of the form a times 10 to the nth power, where the value of a will be between 1 and 10. Now that does not include the 10 itself. And n basically tells you the number of places to move the decimal. Now the sign of n will then tell you whether you're moving the decimal to the left or to the right, as you will soon see. So let's begin here. We want the decimal to be between the 9 and the 3 so that we have a number between 1 and 10 out in front. So this will become 9.374. We don't need those remaining zeros there. Times 10 to the, well, the decimal used to be after all those zeros, moving it 6 places to the left gives me times 10 to the 6th power. It's a positive exponent on the power of 10 when we have very large numbers, and if this was a very small number, less than 0, we'd probably have a negative exponent, or not probably, we would. Now this next problem, I've actually written this way to see if you know how to write 19.4 trillion out. If we just had 19, you know that that's 19. If we put the 400 after it, that's 19,000. 3 more makes that 19 million. 3 more make it 19 billion. 3 more zeros make that a 19 trillion. So we'd like the decimal to be between the 1 and the 9, so I have a number between 1 and 10 out in front, and so this will become 1.94 times 10 to the, well, the decimal used to be off at the right, 3, 6, 9, 12, plus 1 more, 13. So 1.94 times 10 to the 13th power. For this next problem, we'd like the decimal to be after the 3, so we could write 3.81 times 10 to a power. If you look very closely and you count the number of places the decimal moves, it's moving 4 places to the right. Because this is a fraction or a very tiny number, we will use a negative exponent telling us to move the decimal to the right and have a negative 4 power. Now, we need to be able to go in the other direction, so if we have 4.71 times 10 to the 8th, you know that there will be a 471 in the problem, and that we've moved the decimal 2 places already to get that 471. We need to move the decimal 8 places altogether, which means we need to insert 6 more zeros, and this is 471 million. For this next one, we see a negative 5 exponent. We know it's going to be a very small number, so I'm going to write the 321 over on the right. I need to move the decimal 5 places to the left. Well, 1 place is already taken care of by moving it to the left of the 3, so I need to insert 4 more zeros here to hold that decimal off, and it's always good manners to have that 0 listed out in front before the initial decimal. When it comes to multiplying numbers that are in scientific notation, you will multiply the first number in each of these parentheses, and then you will add the exponents on the power of 10. So basically what's going to happen, if you go 3.4 times 4, you will get 14, and then if you add exponents, that will be to the 34th power. That is not in scientific notation because this is a 14, not a 1.4. Now we could, if we wanted, write this as 1.4 times 10 to the first, then bring down the times 10 to the 34th power, and have that as 1.4 times 10 to the 35th power, because 1 plus 34 is 35, and get the answer that way. I don't usually put that middle step in. What I like to say is, the 14 is going to be getting smaller. I'm dividing by 10, so this number over here to compensate is going to get larger, multiplying by another 10, and so I've moved the decimal 1 place to the left over here and adding a power of 10 over on the right. So let's try this again. We multiply the 2.45 times the 3.5, which will give us 8.575, and then we add exponents 10 to the 29th power. Now, is this in scientific notation? Well, yes it is. We only have one value between 1 and 10 to the left of the decimal. We as math teachers are perfectly fine with this as our solution. However, I will make a comment that your chemistry teachers would prefer that you have involved what we call significant digits. We want to not have an answer that is more precise than the values we began with. And notice this has 3 decimal place accuracy. The two things we multiplied together had 2 place accuracy and 1 place accuracy, or 2 significant digits and 1 significant digit. You have to take the more crude one, the one with the least level of accuracy, which is 1 place after the decimal, and write your answer in that form there. So if this were your chemistry class, they would prefer you write this as 8.6 times 10 to the 29th power. But for our purposes, we will be using the mathematical form right here and not what is used in chemistry. But I at least wanted to make that connection so that your chemistry teachers don't get upset with me. When you are dividing with scientific notation, you actually divide the first two numbers, and instead of adding exponents, you are going to subtract exponents. So in this case, 4.5 divided by 1.5 is 3 times 10 to the, now we take negative 4 minus 19 to get negative 23rd as the exponent on 10. Doing that again, 2.4 divided by 4.8 is 0.5, and then subtracting exponents, 8 minus 42 is negative 34. This, however, is not in scientific notation. We can't have 0.5, we need 5.0 times 10 to a power. Now, notice how this number is getting larger by multiplying by 10. This one, instead of getting larger, is going to get smaller. So subtracting 1, you're going to get negative 35. A common mistake is to make that negative 33, because people say 34 minus 1 is 33, but it's negative 34. Take away 1 makes negative 35. So be careful there.